So number 4, an airplane flying parallel to the ground undergoes 2 consecutive displacements. The first is 75 kilometers 30 degrees west of north, and the second is 155 kilometers 60 degrees east of north. What is the total displacement of the plane? They're back down to 2. We're going to go first displacement equals 75 kilometers with an angle of, you guessed it, negative 30 degrees. Okay? Now, why negative 30 degrees? What is west considered to be in our kind of common sign conventions? Negative, right? So it's 30 degrees to the west or to the negative direction of north. 55 kilometers for my second displacement. And my second theta is just a normal, it's east of north, so that'd be a regular positive value. So let's break down these two movements, right? These two displacements into their components. So the x component of the first displacement is going to be show this real quick. How do we do this? So Bella, you were asking about under what conditions might the x component use a sign. This is one of those times. So here's my right angle, and this bad boy right here. This is the that's the angle right there. We'll go sine of the first theta y component to be cosine of the first theta. And for our second movement, second delta x, it's going to be our second displacement. Sine of the second angle. Second displacement times the cosine of the second angle. So it's 75 kilometers. Sine of negative 30 degrees. 75 kilometers. Cosine negative 30 degrees. Then what's our second one? 155 kilometers times the sine of 60 degrees. 155 kilometers times the cosine of 60 degrees. We're going to come up with negative 38 kilometers for our first x component, 65 kilometers for our first y component, 134 kilometers for our second x component, and then 77.5 kilometers for our second y component. So I'll add my x's together and I'll add my y's together. And so this ends up being, what's a weird one? 96? Is that 96? I sure hope it is. And then 42. So we have a positive value and a positive value, right? Now that I have a right triangle, I'll square my x component, add it to the square of my y component, and boom, there is my displacement, or at least the magnitude of it. That ends up being 171 kilometers. But for the angle, take the inverse tangent. This case is going to be a delta x over a delta y. So tangent 6 kilometers over 142. 34 degrees east of north. Box out my answer, and we're done with the homework.